All right, here we have a couple of examples where we're going to be putting everything together, all of our exponent rules together. So here we have a to the negative 5b squared. All of that is being raised to the negative 6 power. Well, when I look at this problem, predominantly I see a product raised to a power. So if you'll remember from what we've done before, that means that each one of those factors gets the power. Now we can do this without having to do 1,000 different steps once we're really comfortable with it. We can say a to the negative 5 raised to the negative 6, power to power we would multiply. So this would be a to the 30th power. Oops, too low. And b squared to the negative 6, power to power, again we would multiply, so that would be b to the negative 12th power. Now, this negative exponent means that this b is in the wrong position. It doesn't belong up here. We have to put it in the denominator. So now that really, when we simplify it, would be a to the 30th over b to the 12th, and that is much better. Now this next problem I'm actually going to do two different ways so that you can see that you have some options, but you have to be following valid rules. Now the first thing I'm going to do is I'm going to raise every one of these items inside here, since we only have multiplication and division going on. I'm going to raise every single one of those to the outside exponent, power to power. So we're going to have, let's see, a to the 5th to the negative 3 would be a to the negative 15th, and b to the negative 3 would be b to the negative 3, over a to the 7th to the negative 3 would be a to the negative 21, and b to the negative 2 raised to the negative 3 would be b to the 6th power. Now it's here that we have a couple of different options. On the one hand, we're going to work this using our quotient rules. And our quotient rule says when we're dividing like bases, we're supposed to subtract the exponents. So this would be a to the negative 15 minus negative 21. And for our b's, we would have b to the negative 3 minus 6. Well, now, negative 15 minus a negative 21, remember your minus and negative is going to turn into a positive. So negative 15 plus 21 would be a to the 6th power. And b to the negative 3 minus 6, that would be b to the negative 9. Now this negative 9 is in the wrong position. It says that the b is in the wrong position, rather, because of the negative exponent. So in order to correct that, we need to put it in the proper position. So we're going to put it over b to the 9th. Now that's one way of looking at it. Another way of looking at it is, let's start back from this exact same step. So we're going to kind of move that there. In looking at what we have here, this a to the negative 15, that's in the wrong position. We can correct the positions first, and then we're only working with the positive exponents. So a to the negative 15, wrong position. It goes on bottom instead of on top. b to the negative 3, wrong position. It belongs on bottom. We're going to correct it. A to the negative 21, because this is a negative exponent, it's in the wrong position, so we're going to correct it by putting it in the numerator. And b to the 6th is a positive exponent, so that's just fine. Now we can go through and we can simplify. When we're dividing like bases, we would subtract the exponents, so 21 minus 15 would be a to the 6th. And then we have on bottom here, we're multiplying like bases, so we would add the exponent, so that would be b to the 9th. We get the exact same thing no matter what we do, as long as we're using valid exponent rules.